Again, welcome to JSP. In these lectures, we will go through the T-independent test or independent T-test, which is also called the student's T-test. The main goal of T-test or student's T-test, we can use it to find out if there's a difference between two independent samples. Now, independent sample, according to our textbook, means we have two samples. The size can be different, or they are coming from different population. So the first thing we need is our data. So first I'm going to use the data library again, and I'll select the t-test, and I'll take the first file, which is the directed reading activities. Now, in this file, we have 4 variables. The first one is the ID, so we don't need that. That's the unique number for each person. Then the second is group. So this group will be based on 2 types of group, control group and the treatment group. And based on these two, we want to know DRP will be the performance, reading performance. So here we have directed reading activities. So the performance of, again, degree of reading or directed reading. So those are the 2 main variables we are going to be more concerned. That is the group, either treatment or control, and also we check with the performance. So this means the treatment or the control will determine, we want to know if it will either improve the performance or will not improve performance. So that will be our dependent variable, will be the DRP. Then the grouping or independent variable will be the treatment control. So for example, we cannot say that based on the performance of the student reading activity, we may decided to give him a treatment or control, but rather it should be the opposite. Based on the treatment, we want to see if performance of reading activity may increase or decrease. So the next thing here, we get our t-test, independent sample t-test. So as usual, when we open, we can see all our variables. Now we select the ones we need. We need the DRP. That will be our dependent variable. Then we need a grouping variable, which will be the group. So just by selecting the 2 variables, we already have our solution or the answer here. We can see the p-value. Here, the p-value is less than 0.05. By default, we are having 95% confidence interval for location parameter, for effect size, everything. So the alpha will be 0.05. So this tells us that there's a difference. There's a difference between the treatment and also the control group, treatment group and control group, their performance, reading performance. Now, the next thing is we want to know more about this performance. So I'm going to click on the descriptives. Descriptives can give us some more details. So here we can know the mean now. So we can see that in the control, the mean is 41.522, but the mean for the treat is 51. So we can see that the treat did good than the control. Also, we can see the standard deviation, standard error, and also the coefficient of variations. Also, one thing we always know is the effect size. Effect size also can tell us. Effect means, again, the significant, the difference, the relationship, how strong it is. So, for example, we know effect size. If the value is less than 0.2, we would say it's a low effect. Now, between 0.2 to 0.8 is medium effect. Then if it's greater than 0.8, it's more large effect, good effect. So here, when we click on the effect size, we get the Cohen's D. This is the value I'm talking about. So we can look at the Cohen's D value. We should have it in our table. We can see it right here. And we can see the value there. It's not too good. The effect size is not that strong. It's not that strong. So again, that's the whole concept here. The whole concept of the effect size. We can also try the confidence interval itself to us. We can also do descriptive plots. The hypothesis also, the alternative hypothesis, we can change it if you want. Here we are doing two-way, not equal. Also, we can also check the equality of variance. Sometimes it's very important. So normally we are assuming it's equal. So for example, here I'm going to click normality, and we can see the assumption check test of normality Shapiro. Perfect. We can see the p-value is greater than 0.05. So which means it's normal. It's good. We can also check for the equality of variance. So we have the value also. So again, we can do so many here. The main thing is to understand again what we are trying to achieve. The last thing I can do will be the plots. We can have a bar plot or descriptive plot. And we can go down and see. Now we can see the control is down, treatment is more upper. The values are between 30 to 60, so we can see the mean. There's difference. And I think that's it. So our main goal is here. What we are looking for is here. What is it? The P is 0.029. There's a difference between the two groups, the treatment and control, in terms of performance. Now, when we get the descriptives that tell us the mean value, we can see that the treat has higher mean than the control. And also when we plot the descriptive plots, we can see also from here. This is the treat, this is the control. So that's our main goal here. So I'm going to end this lectures here, and we will see again in the next lectures. We may try to do the peer sample t-test. We may do the peer sample t-test, then we may do one sample t-test later. So again, wish everybody the best, and thank you.